Hey all, welcome to the next session about AI testing. The previous recording and video sessions, what we had seen and learned was all about why AI era, how we have to mold ourselves and learn, adapt according to this AI era. We had the traditional testing in place. We are going to learn the difference between the traditional testing and the AI testing in this video session. This is going to be our second session. In our previous session, we also learned that we have to test the AI applications. Coming to the AI applications, it can be our chatbots, it can be our RAG applications, it can be any of the applications built on AI, which are developed on AI. So in that case, we need to understand how we can test our AI applications. Do they give a definite output or do they give an indefinite output for a particular input? So let's learn the difference between our traditional testing and our AI testing. I've also told you all that when we are using the terminology AI testing, we are going to use the word evaluate. So we are going to use the Python library deep eval, that's DEEPEVAL. Deep eval is a Python library which is extensively used to test our AI applications. And this is the one which is going to help us out to determine the output when we are testing our AI applications. So from this slide, let us understand the difference between AI testing and traditional testing. So how is it going to be different from the traditional testing? So what happens in our traditional testing? We have a definite set of inputs. The inputs are going to be our requirements, which are in the form of user stories. When you're following the SAFe framework, the agile methodology includes user stories for testing. And then from the user stories, we develop test scenarios. Accordingly, we develop test cases. We execute the test cases. When this execution happens on our application, it can be either performance execution, automation execution, or a manual execution. And the output, what we get is a definite output. So what is the actual result and what is the expected result? So if there is a deviation between the actual and the expected result, that we define it as a bug and we log it into our defect tracking tool. It can be Jira. It can be any other test management tool in that case. So we know that this testing, which is a traditional testing, starting from our SDLC phase till we follow the agile way of testing. So in that case, we say that this testing is a deterministic way of testing our applications. It gives us a deterministic output. So that means one definite output for a set of inputs. So it becomes easier for us for the test coverage. It becomes easier for us to track defects, log defects, for retesting, because we know that when we assert or when we validate, we are validating one particular output. That is why it follows certain predefined rules. That means it has a user story in place, it has its acceptance criteria, it has its test scenarios and test cases. Now let's come to testing AI applications. So if we want to test our AI applications, we call this as testing giving us non-deterministic outputs. That means there is no one particular output. Each time you give an input, and each time when you execute your result, it gives a different output for each run. So we can say that our second run or second execution is determined upon the previous run, which is your run 1. Likewise, when you're executing your third run, it is determined, so that it is means that is the output is determined on your previous outputs, which is your run 1 and the run 2. So we have 3 executions, run 1, run 2, and run 3. So our third run gives us the output by learning the outputs which we had received from run 1 and run 2. So we can say that AI is testing and adapting itself by learning the output which it had fetched from the previous outputs. So we can say that the result or the expected result when testing AI applications is going to be non-deterministic. It does not follow one particular validation. It follows a range of outputs, and that those outputs should be within that particular range. So I hope you all have understood the difference between AI testing and the traditional testing. Let's come to the next slide. Over here, we are going to understand AI output is non-deterministic. So as I explained to you all in our previous slide, the output for an AI application, when we are testing it, is going to be non-deterministic. That means we are getting multiple outputs. Now, as I have shown here, the difference between deterministic output and a non-deterministic output. Deterministic output we get when we are testing our traditional approach, our traditional applications. But when we are testing AI applications, when we are using AI in place, we are getting non-deterministic output. For example, when we come to deterministic output, when I'm clicking on a login button, here I enter my username, I enter my password, I click on the login button. It takes me to the dashboard page. So I have the test scenario that when I enter the user credentials, I click on login, it takes me to the dashboard page. So the actual is it has to verify that the user is landed to the dashboard page, and expected should be the same. And I say that there is only one particular output. I have to validate that I have reached the dashboard page or not. If I have reached the dashboard page, that means it is as expected, and I have found only one output. So I am determined to get this one particular output. So I can say it is predictable and always consistent. Same actions will always take me to the same dashboard page. So that means each time I enter the username, I enter the password, I click on login button, it takes me to the dashboard page. I am finding only one particular output in my traditional approach. So I call this as a determined output or a deterministic output or a deterministic way of testing our traditional software. Now let's come to the way of testing our AI applications. I have asked the AI to write a summary of AI testing for me. This is my question, what I give as a prompt to my AI application. It can be a ChatGPT, it can be any AI application for that matter. I'm asking a prompt that give me a summary of AI testing. When I execute for the first time, it is called as run 1. In my run 1, it says AI testing ensures that AI systems are accurate. It started giving me the information about the summary of AI testing. It's reliable and unbiased. It involves validating data, models, and outputs. This sentence I had received when I did my run one. When I come to run to my second execution for the same input, which is write a summary of AI testing, I get the output as AI testing is the process of evaluating AI applications for accuracy, fairness, robustness, and performance across different scenarios. When I come to the third run, it gives me the statement for the same input, write a summary of AI testing. To test AI, we validate its predictions, verify datasets, check for bias, and ensure it works as expected in real world situations. So I can say that all the three runs are giving me the output for the question asked to the AI application, write a summary of AI testing. So I cannot say that run one output is correct. Neither I can say the run two output is only going to be correct, nor I can say that exclude run one, run two, and only go for run three. So it's giving me a range of inputs, so I can call it as a non-deterministic output. That means I get a range of outputs, which is going to give me the accurate result, but not one accurate result. It's going to be a range of accuracy. So we can say that non-deterministic output, it's going to vary. So it's going to be a variable output, and it's going to be dependent on the context. AI output may change each time, but can still be correct. I hope you all have understood that what is the difference between deterministic output and non-deterministic output. Let's come to my third slide, which we say that why AI systems are non-deterministic. Why don't they give us only one particular result as we had received the same when we are testing our traditional software and testing our applications which are non-AI? So we have to learn that when we are testing the deterministic way of getting our output, we say call it as a testing of deterministic system. When we are testing our AI applications, we are saying we are testing non-deterministic AI systems. So in that case, when we are testing deterministic, you have same input always and produces the same output. So we can see the 5 points given here for deterministic system. It saves time. You are not always running behind that out of these many executions, I'm getting each time different output. So which one should I choose? I have an actual result in place. I have to validate it with my expected result, and that is all. I stop my testing there. I get the actual result. I validate it with I get the expected result. I validate it with my actual result. And if both are tallying, I mark the test case as pass. If it is not as expected, I log a defect, and that's the end. I stop there. So it's saving my time. Unlike the AI testing, which is non-deterministic, it gives me range of outputs. Though it is the same way of understanding the output, but it gives me a range of outputs, which is all correct, but not one accurate output. Now, for the second point, it reduces human error. And that's very true, because in deterministic way, what happens is one output for one input, for one set of inputs. That is your test scenarios, test cases for that one particular user story. I don't have to intervene much into the system. I just, for that finite input, I get that one output. It improves the test coverage. I can execute more test cases. I can cover up more test cases. I can go for automation. I can go for performance because I have a determined output. I don't have to boggle my mind as to which will be the correct output for this range of input. It enables early bug detection and it increases my productivity. Now let's come to the non-deterministic way of understanding the output. What happens in my output during the run one? I understand that it saves my time because it's giving me an output. It is giving me an accurate result, which is during the run one, which is improving my accuracy. It enhances my test coverage. It helps in quick feedback and also increases my efficiency. Now, when I execute the same input given to my chatbot, or it can be any of the application, it is going to reduce the human error because human intervention is not here. It's trying to understand from its previous output, which is run one, and it's giving me another accurate result, which is in run two. It saves the time and effort. It improves the test coverage and it enables early bug detection because it's giving me the result, and it lowers the testing costs. I don't have to, I don't have to uh, spend time or my efforts or logging in my efforts for my understanding of user stories, which is my sprint planning. I have to understand my user stories, what I'm going to take for my sprint. I have to understand the test scenarios. I have to understand the test cases. I have to write them down. I have to map it to my user story, get it reviewed. So all this cost, time, effort is saved. Likewise in your run three. So I can say, what happens in my run three? It increases the test productivity. It improves the software quality. It supports continuous testing. It reduces manual effort. There's no manual intervention because everything is done by your AI, and delivers faster release. So within a span of time, rather than logging in efforts and time for your test cases, test scenarios, everything, you just need one input and you get a range of output. All the three are correct. It's just that it is giving you more accuracy, more precision in each run. This side, we see that what are the different key reasons why AI systems give a non-deterministic way of output? It has a probabilistic nature of models. So now here, what happens is these chatbots or chat agents, AI agents, are all built on probabilistic way nature. That is, it gives us a range of outputs, either yes, no, true, false. So what happens over here is that there are tokens. So these tokens, as many number of tokens, that many number of results. And the probabilities are not fixed as to how much your range or what is the limit of your output should be for each run. As many tokens, it gives you that much output. So that is the way it has been developed. There is randomness in sampling. That means there are sampling techniques which are introduced to make the outputs more diverse and natural. There are large number of possible outputs, as we have explained and learned. There is context sensitivity. So based on a particular input, it understands the context. So if you are integrating with a particular banking application, so it understands the banking application and gives the output around that particular application. If it's a healthcare application, it tests the scenario around that application and gives. So it is context driven. Model updates and training data. So as I said, that it trains upon the previous data and then gives you the result in the next run. And finally, it is having a dynamic environment. Real-time data, user history, previous interactions, and external tools like web search can influence the output. So you would have seen whenever you're searching any data from an AI mode on your Google page, it searches in and around your LinkedIn, your YouTube, your Instagram, all such media, and then finally gives you the result. So there is a precision based on your previous run. I hope you all have understood what is the difference between the traditional testing and the AI testing. What is the difference between deterministic output and a non-deterministic output? Where do we get these outputs? And why AI systems giving us non-deterministic outputs? So let us learn more about testing AI agents in our upcoming videos. Thank you for your time, and your feedback is highly appreciable.